Okay, as we learn more and more about SQL, right? Let us have a real world context. Let's take a real world problem. Let's take a real world problem so that we understand SQL better in the context of some real world problems, right? We have taken a real world data set like the IMDb data set here. So imagine you're a software engineer. Imagine you're a software engineer, right? And your goal is to build a website. Let's assume you're building a website. You're building a website, right? Or a mobile app, right? Where you want to show all of this information that is there in this data set that we have, right? And help people search for movies that they may like, right? Let's assume that's what you're trying to do. You're building a website or an app where you want people to discover movies that they think are interesting, or to understand more about this movie's data that they have, right? Let's assume you're doing that. Okay, you're a software engineer, or you could even be a data scientist, right? Or you could even be a data scientist who's trying to understand the data that you have in this IMDb data set, right? So we'll put things in this context so that you better understand how some of the concepts that we are learning in SQL are actually applied in the real world. To be honest with you, this whole website on which you're watching this video content, right? Or if you're watching it on a website or a mobile app or a mobile browser, all of them use SQL internally. And many of them may be using MySQL itself. On our own website, we use MySQL extensively as a backend database for most of our data storage needs, right? Okay, having said that, so let's take a task, okay? We'll always try to put things in contexts of some real world tasks. Suppose my first task is I want to list all the movies. I want to list all the movies, right? I want to list all the movies in my database. In my database. I'll write database in short as DB. Right? If I want to list all the movies that are there and all the data I have about these movies, okay, we know that there is a table called movies. We've already seen its description, right? So let's go and see the describe movies, right? Okay, so my movies table has a movie ID, it has a movie name, the year in which the movie was released, and the rank score, which is often referred to as the IMDb score. IMDb scores each movie between a range of 0 to 10. 10 being the best movies, 0 being the worst movies. This is called the IMDb score. And this score is provided by movie viewers like us. And all these scores are aggregated and an overall score is given. The range of all these scores is between 0 to 10. That's the data we have about these movies, right? So now the first task that we have is to list all movies, right? And towards this task, what I have done here is I'll share a very simple file here, right? This is a file that I've created so that this is like your notes. Think of this like a notes with all the commands. And the reason I've written these commands is so that I don't have typos or errors. I've already pre-tested some of these queries so that there are no errors in this, right? We have already seen these three commands earlier: use database, show tables, and describe a table. We have already seen this in the previous videos, right? Now we'll learn about a command called select command. Very interesting command. I'll explain you what it does, right? So let's understand what the select command itself does, right? Okay, let's run it. I'll explain you the syntax, everything slowly, right? So let's take this command. So when you're running some of this, you can just take this, copy this whole thing, Control C, and I go here, I paste. What is this command literally doing, right? So it's printing some information for me as soon as I gave it. So let's understand this command first, okay? So the command that I used is select star from movies. Let me break it down for you, right? Let me break this down for you. What did I do? I said select star from movies, okay? So select basically says, right? Okay, select basically says that I want to select these columns. These are all the columns that I want to select and I want to display that. From basically is a keyword. See, select is a keyword in SQL, so is from. This is the table name. This is the table name. So what it is literally saying is I want to select star Star in many computer languages basically means everything. Star means everything, right? So when I say select star from movies, what it means is select all the columns. This star basically means select all the columns from movies, and there is a semicolon at the end, like all SQL queries. So what are you saying literally here? You are saying, I want to select all the columns from the table movies. The moment you do that, okay, the moment you do this, let me show you here, right? I'm clearing the screen with Control L. What was it? Select star from movies. As soon as you type enter here, it will start printing out all the movies, all the information that is there in the movies table. It's going to print everything that's there in the movies table. It's going to print all the columns here, right? Very, very simple. Now, there is one problem with this. So if you look at our tables column, if you look at our table called movies, right? If you describe movies, we have 4 columns here. We have 4 columns here. We have ID, movie name, movie year, and movie rank score. But in reality, there will be tables. There will be tables in the real world, right? With hundreds of columns. With hundreds of columns. And when I just simply say select star from movies, it's going to print all the hundreds of columns, which I may not need. And because you're printing all the hundreds of columns, even here, it's going to print all the 4 columns, right? And you may not need all of the columns. Imagine if a task was, okay, that you want to see the name and the year of all the movies. If you want to list the name and year of all the movies in your database. You don't care here about ID, you don't care here about the rank score. You only want the name and the year. Suppose if this is your requirement, then how do we change? How do we change this? It's very simple. So we say select. What all columns do we want here? We want only 2 columns, name and year. So you say select name, comma, year from which table you want? Movies. Right? So here what am I doing here? Select basically says which columns to select. Right? Name and year. These are the 2 columns that I want. I've not put a star. If I put star, it means all the columns. Here I want only these 2 columns from, which is also a keyword, which table? Movies table. That's all. Right? Okay. So let's go and see this. Okay. Here, let's say, suppose, okay, here, let's say I want name and, okay, let's change this, name and year, name and year from movies. Okay, if I now enter this, okay, suppose if I enter this, now it's only printing 2 columns if you notice. It's printing the name of the movie and the year in which it was released. That's it, right? It has printed all the 388,269 rows. Look at this, it has printed all the rows here. So if this was your table, right, with 4 columns, right, you had ID, name, year, and rank score, right? Now here I'm saying I want only the name and year. So it only prints this information across all the rows. That's what it's doing. It's a very simple command, right? And one thing you have to notice here is, remember, here we are not saying how to print it. We are not explaining how to generate output. We are not saying how to generate the output, right? As we discussed, right? SQL is a declarative programming language, if you want to think about it. Right? It's not a procedural thing. Here you just say what you want. Here you're saying, I want the columns name and year from this table. It is the SQL engine, the query optimizer, everything that takes care of how to do it. Right? The parser, the compiler, everything that's there within the database. You only say what you want. So you're saying, I want to select these 2 columns from this table. How you get it is none of my business. That's why SQL is so simple, because you just say what you want without explaining how to generate the output. That's very, very important, right? And another thing is, whenever you run any SQL command. Let's assume I run this, select star from movies. Okay, so this generates, see at the end of it, when you run this, right, it generates some output. That output it generates is called a result set. It's called a result set. And what is a result set if you think about it? Result set is nothing but another table that it creates. When I say select star from movies, or when I say select name comma year from movies, what it is generating, the terminology in databases is called a result set. A result set is basically a set of rows. It's a set of rows with column names. That's, or in other words, it's actually a table that it's generating a new table using this table. So when I said select name comma year from table, it is generating a result set for me, which consists of all the rows, but only these two columns, right? So whenever I use the word result set, it basically means it's a set of rows with column names, or this is the output generated from a select query. This is important to understand, right? There is one more small interesting detail here that I'll go through. When I say select star from movies, right, I'm going to obtain all the columns so this is, let's say, case 1. This is, let's say, case 2. So when I say select star from movies, it's going to result all the columns. It's going to result all the columns because of the star, right? Now, which means the data that it will result, the amount of data that will result is larger, or the data is more than the data that this will result in. And hence, this query 2 is going to be faster. This query 2 is going to be faster than query 1. So it's always advised to only request for those columns that you need. Tables could have hundreds of columns. I've seen tables with hundreds of columns in my own experience. There is no point in running select star from movies because the amount of data that needs to be transferred, because every column data has to be transferred. Look at this. We had 4 columns here, right? It has to return data from 4 columns, while here it has to return data only from 2 columns. And this is far more optimal because the amount of data that you need to transfer here is less. In this query, the amount of data that you need to transfer is less than query 1. And hence query 2 is going to be faster. So it's always important to only query for those columns that you need and not use star every time, especially when you have tables with lots of columns, right? That's a very, very important facet that you should keep in mind when you're using the select SQL keyword or the select queries, right? Okay. Having said that, right, there is one more important aspect that I wanted to go over. Okay. Again, I've provided notes for all of this here. For example, if you see here, we say, okay, select star from movies has more data transfer, right? And what is a result set? A result set is a set of rows that form the result of a query along with column names and some metadata about the table. Okay. Column names is also a metadata. Don't forget that. Column names is not the data in the table. It's actually the metadata about the table. Metadata basically means data about the data, right? Similarly, now let's look at this, right? Okay, again, the other interesting thing is by doing this, I'm only obtaining 2 columns of data instead of all the columns. Now again, the order that you have here, the order of columns, look at the order of columns that we have here, right? Let's go to a terminal. Okay, so let me just clear the screen here. If I describe movies, I have my columns. My first column is ID. My second column is name. My third column is year. My fourth column is rank score. But I don't have to select columns in the same order. For example, look at this. Okay, suppose if I take this query, let's say if I take this query, select rank score comma name from movies, right? So let me type it here. I'll copy pasting it here. It's running perfectly, right? So one interesting thing that you should remember here is that my order of column names can be anything. My output, like when I run this, look at this, when I run this, in my result set, my first column is going to be name. My second column is going to be year. This is the table that I'll get with some data here. But when I run this, my first column is going to be rank score. My first column is going to be rank score. My second column is going to be the name of the movie. And I'm going to get some data. Look at what I have here. Look at what I have here. My first column here are my rank scores. My second column are the movie names. Right? Again, it resulted in all the rows that are there in the data set. Right? So that's important. Very, very important. So if you look here, the order of the column names can be anything. Okay, it need not be in the same order as they are in the table, because if you look here, right? If you look here, the order that is there in the table is different. Here you have name before rank score, right? But if you look here, the order here is different. The name score here is before the name. The rank score here is before the name. So the output result set or the output table will have the order as mentioned here, and this order can be anything. The only requirement here is this can either be star or it can be one of the valid column names for the given table. Right? That's one. The second thing here is when I output all the rows, look at this. Okay. Suppose my original table, let's assume this is my original table. Okay, let's assume this is my original table with ID, name, let's say year, and rank score. Okay, I'll just write rank score in short. Okay, let's assume I have ID 1, ID 2, ID 3, so on and so forth. Okay, on top of this now, let's assume I ran a select query. I say select name comma year from movies table. Let's assume that's my select query. The output that is generated here, will contain what? Will contain only two columns, name and year. The order in which the rows appear here, the order in which these rows appear will be same as the order in which the data is stored in the table. So first row will be output here, second row will be output here. The first row, let's say name is N1, name is N2, name is N3. So I'll have name 1, name 2, name 3, right? And so on and so forth. So the order of the output here, the order of the rows is same as the order of the rows that is there in the original table. For these simple select queries, we will look at other select queries where the order will not be preserved. So these simple select queries will preserve the row order. Okay, so this is called row order preservation. Okay, because these are very simple. What am I doing? I'm simply saying, get me these two columns from this table. So of course, if ID1 has name 1, here also you'll see name 1. Name 2 comes is the second, this row of belonging to name 2 comes after name 1. Same here. So the row order is preserved in simple SQL select queries. There will be other queries where it will not be preserved. I'll explicitly mention that. Okay, so that your understanding is deeper and better. Okay, having understood this, now comes the next interesting question. Okay, so let's go here. So we've understood the very, very basic, extremely simple select queries till now, right? Very, very simple select queries. We have understood what star means, or the fact that we can use column names. We understood what is a result set here. We understood about the row order preservation. And we said it's always good to use column names instead of using star, because this will be faster, because there is less amount of data that should be transferred. Right? Very, very simple stuff. Select is the most used and the simplest